Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to be talking about Unit 6, Lesson 2, the triangle-angle theorems. We've got two main goals for this lesson. Students will be able to calculate the measures of angles using the triangle-angle theorems, and students will be able to prove those theorems. All right, we're going to start with one that we're already familiar with. We did this in Unit 5, and it was part of your Unit 5 assessment, or it might have been. And then it's also going to show up on your Unit 6 test. It'll probably be the first question you're asked. We start with any given triangle ABC and we draw DB parallel to one of the three sides. And that creates these two exterior angles, angle 4 and angle 5, such that if we add them together, we get 180 degrees because we have a straight angle here. Okay, that's the first part of the proof. So we would say angle 4 plus angle 2 plus angle 5 is equal to 180 degrees. There's actually two things going on. We're doing the angle addition postulate, all right, and we're doing straight angles. Now, we know that angle 4 is congruent to angle 1 because they are alternate interior and DB is parallel to AC. Also, angle 5 is congruent to angle 3 because they are alternate interior and DB is parallel to AC. So angle 4 is congruent to angle 1, AIAT. Angle 5 is congruent to angle 3, AIAT. And then by substitution, angle 1 plus angle 2 plus angle 3 is equal to 180. By substitution. All right. So that's the tasty theorem, T-A-S-T. Now we're going to do a corollary. A corollary is a kind of theorem that follows directly from another one. So we just did the tasty theorem. So a corollary to tasty is the right triangle AST theorem. Okay, so angle sum theorem. AST means angle sum theorem. So in a right triangle, we say the sum of the two acute angles are well, that should be is. There's a terrible grammar error right there. Is complementary. All right, so the two acute angles are angle 1 and angle 3. We want to show that those two angles is equal to 90 degrees, are equal to 90 degrees. And we know that angle 2 is 90 because BC is perpendicular to AC. So BC is perpendicular to AC right here. Right, now the tasty theorem tells us that 1 plus 3 plus this angle, which is 90 degrees, is equal to 180. So 1 plus 90 plus 3 is equal to 180 degrees. This is 90, so we substitute it in. We're going to subtract, so 1 plus 3 is equal to 90. All right. Angle 1 plus angle 2 plus angle 3 is equal to 180. Tasty. And then we say that angle 2 is a right angle. And that means that angle 2 is equal to 90 degrees. This is because BC is perpendicular to AC. Now you can do a lot of things here. You can write perpendicular definition, or you can actually give the lines that are perpendicular. Both of those work for me for a proof. Now we're going to make a substitution. You see angle 2 is equal to 90 degrees. So I can just replace angle 2 with 90. Like so, by substitution. And then I can subtract 90 from both sides, and that gives me angle 1 plus angle 3, which is equal to 90 degrees by subtraction. Okay, now one of the cool things here is the name. This is the right triangle angle sum theorem, so that's R-T-A-S-T. So where the triangle angle sum theorem is tasty, this one is real tasty. All right, we're going to use these theorems now. We're going to do some computation, and there's a couple of different things that we can do here. First of all, we can compute y very easily by going y plus 54 plus 90 is equal to 180. This is tasty. Tasty is when you add the three angles of a triangle up and you get 180 degrees. So this one's tasty. But we can use well, you could also use the real tasty theorem here because you have the 90-degree angle down here. So real tasty is triggered whenever you have 90-degree angles. So you could go y plus 54 oh boy. One moment. Pen fell asleep. Y plus 54 equals 90 by the theorem we just proved. That's real tasty. And that's right triangle angle sum theorem. So you could do either of these to calculate y. All right. Now, if I come over to this triangle to calculate x and z, if I'd use tasty, I get this. X plus y plus 25 equals 180. Tasty. But we can't do anything there because there's two variables. So we need to, wait a minute, hang on. It's not y, is it? No. It's z. Okay, sorry about that. So x plus z plus 25 is equal to 180 by the tasty theorem. Again, I kind of crossed my z's, so that's what's going on there. But I can't if I got two variables. So I need to isolate somehow, and I can come down here and do that. You see, z and 54 are a linear pair. So angle z plus 54 is equal to 180 by the linear pairs theorem. Okay, and then you compute. All right, so I'll leave it to you to actually make those computations, but these are the setups. Make sure when you're taking a test or a quiz or doing your homework even, when you do the setup statement, you cite the theorem. After the theorem is cited, you don't have to do anything more. So like when I go 54 plus 90, and that's equal to 144, you don't have to say substitution. Just do it and get the algebra done. All right, next up, we want to talk about exterior angles. There are basically two types of angles in a triangle. That was the wrong button. Let's try this one. Interior angles are the ones that are formed by the polygon itself. So 1, 3, and 2 are your interior angles. All right, and angle 4 is your exterior angle because it is outside the polygon, so it's out here. All right, now, we also want to talk about a new word called remote. All right, the word remote means far away. Think like remote control allows you to control your television from far away. Or like a remote island is something that's very far away. 1 and 3 are called remote to the exterior angle 4 because they are not next to. See, 2 and 4 are next to each other. They are adjacent. 1 and 3 are not adjacent to angle 4, so we call them remote. All right, now this applies to our next theorem. Okay, actually we're going to do a calculation first, I guess. Okay. Then we're going to prove the theorem. Uh-oh. All right, so we'll see here. GeoGebra might open up on me, so we'll see what happens. Angle 1 is 40 degrees. Angle 3 is 60 degrees. We want to compute angle 4. Now there's a theorem that's going to help us, but before we use that theorem, we're actually going to have to go through angle 2. Because angle 2 plus angle 4 is 180 by a linear pair. And all of these are 180 because they're inside of a triangle. So 180 minus 100, that's 40 plus 60, that's 80 degrees. So 2 is 80. And then 180 minus 80 is 100. So angle 4 is 100 degrees. If I set this up properly, it would look like this. Angle 1 plus angle 2 plus angle 3 is equal to 180. Tasty. And then you would put in 40 and 60. And then you would subtract 40 and 60 and you get your 80 degrees. Okay? And then angle 2 plus angle 4 is equal to 180. Linear pair theorem. 2 is 80, so we plug that in. and then angle 4 is equal to 100. Now, real quick question. Angle 1, which is 40, and angle 3, which is 60, is equal to what measure? Well, it's 100, right? Check it out. 1 plus 3 is 100, and angle 4 is 100. So I think there's a connection there. All right? In fact, the remote interior angles seem to be equal to the measure of the exterior angle. That's our next proof. All right, check this out. We want angle 4 to be equal to angle 1 plus angle 3. All right, so what I really need is a statement with angle 1 being added to angle 3, and I can do that using the Tasty theorem. All right. Pen's going a little crazy again. Give me a second. All right, so angle 1 plus angle 2 plus angle 3 is equal to 180, because it's Tasty. All right, and now I need to get angle 4 into the picture, and I can get angle 4 in using the linear pair. Angle 2 plus angle 4 is equal to 180 by the linear pairs theorem. Now I can make a connection between the two with the 180 degrees. So angle 1 plus angle 2 plus angle 3 is equal to angle 2 plus angle 4. All right, by substitution. Now check this out. I've got an angle 4 like I wanted over here, and I've got an angle 1 and an angle 3 like I wanted on the other side. But I got angle 2's on both sides messing things up. So what I can do is I can subtract those angle 2's from both sides. And in doing that, I get angle 1 plus angle 3 equals angle 4 by subtraction. And this proves that an exterior angle is equal to the sum of the remote interior angles. And there's the word remote. Remember, it means not next to. Okay? Applications. I believe this might be one of my last slides. There are two ways to compute using the angle, this should be east, not eat, exterior angle sum theorem. All right, so the first one is just to say that the exterior angle is equal to the sum of the two remote interior angles like so. So x would be equal to 84. The other way, though, is to have the variable be one of the remote angles. And this requires a subtraction step. So 105 minus 48, I do not trust myself to do this one in my head. So 57 is equal to x.